Hi, welcome to the chemistry edition of Darling Fee's channel. My name is X-Coco and I'm excited to present to you naming of compounds using the Iupac system. And this is part 1. In part 1, we'll look at the binary compounds and naming of acids. In part 2, we'll consider naming of salts and naming of ions. So let's start. These are key points that you have to know when naming compounds. First of all, you have to know whether the element involved has a variable oxidation number or it varies. You can only detect this or know this by using the periodic table. Then the second point, calculation of oxidation numbers. You should be able to calculate oxidation numbers. Now let's move to the periodic table. Looking at the periodic table here, the elements in red, which is indicated here, indicates that they are all having a fixed oxidation number, meaning that we don't calculate the oxidation number for this element. So take note of that. There is a free gift here. I have already explained this, but I want to take you through. This is very, very important. We have so many radicals to consider, but how do we capture that? I have this free gift, which is CS equals -2, P -3, all is 1. What is the meaning of what we have here? C here stands for these compounds with C, C, C. It indicates that they have a charge of -2. Now, if you take S, those with S, S, S here, they have a charge of -2. Then we have P is equal to -3, which is PO4 3 minus. Take note, the Cl is not part of the C's that we talked about. All is 1. You assume that all the radicals that we have has a charge of -1. Yes, it really works. It is NH4 plus, which has a charge of +1. So this is my free gift. Now let's move on. For the ions here, we need to know their names. So a typical example is ammonium, which is NH4 plus, NO3 minus nitrate. Now if I say perchlorate, what is that? That is ClO4 minus. If I say chloride, that is ClO2 minus. So you can go through all these things for you to know their names. Now if I mention phosphate, that is PO4 3 minus. But if I say phosphite, that is different from phosphate. So phosphite here is PO3 minus. We also have acetate, which is H3C2O2 minus. So please take note of this. This is very, very important. Now in my trick, in taking binary compounds, what we will do is we are going to start from the left, then move to the right. That is from A, you move to B. Just use these two alphabets and you are good to go. So from A, I move to B. Now let's look at A here. What is the meaning of A? A here denotes the element on the left of the screen. The B here is the next word element because it is binary. Binary means 2. So A, first question that you have to ask is the element having a fixed oxidation number or it varies? If it has a fixed oxidation number, there is no need calculating. That is what we have here. If you check and A varies, then it means you have to calculate the oxidation number. Now let me pick that again. If you check and A varies, calculate. If you check and it is fixed, don't calculate. How did we get the 2 here? Ca has a charge of 2, Br has a charge of -1. We are not interested in the charges. So that is 2, 1. They are not the same, so they will cross. And that will give us this compound. Now let's come to B. With B, that is the second element, we introduce what we have here, which is ide. So it is like you saying bide. That is B, bide. So a typical example is what we have here. When you have sulfur, it becomes sulfide. When you take oxygen, that becomes oxide. Bromine becomes bromide. So that is the meaning of the ide. In our case here too, when you take A, that is ion. This is Cl. We know that ion here has a charge of 3, chlorine -1. So when they cross, you will get what we have over here. Now let's look at how we can use A, B to name binary compounds. I hope you are ready. Now let's start. We have KBr here. So assign A and B. K here is a fixed. Yes, it is having a fixed oxidation number. So there is no need calculating. Please take note of this. When you check A and it is having a fixed oxidation number, move ahead and name the compound. So this one will give you potassium bromide. Okay, now let's take the second one here. You ask yourself, is A varying or it is fixed? A here, what do we do? As I said, if A has a fixed oxidation number, then you don't calculate. But if A varies, then you calculate. PB has a variable oxidation number. It is not part of the fixed element. So what we do? We calculate. So that becomes 2 times 2, which will give you 4. So it becomes lead iron oxide. Once again, 2 times 2 will give you 4. Because this one varies, that will give us lead 4 oxide. Good. Now let's look at the third one here. From A, you move to B. A here, which is aluminium, is it fixed? Yes, it is. So there is no need considering the numbers here. So from A, you move to B. So this one becomes aluminium oxide. Let's pick a different example. We have Fe2O3. Fe, is it having a variable oxidation number? Yes, it is not fixed. So we have to calculate. How do we do the calculation? That will be 2 here times 3, which is 6, divided by 2, and that will give you 3. So we have iron 3 oxide. Alright, let's look at some few. We have P2O5. So assign A, B. But because P here varies, we have to calculate. Let's do the calculation together. That is 2 times 5, which is 10, divided by this 2 will give you vein, which is 5. So the name becomes phosphorus vein oxide. What about H2S? We assign A here, then B. So this is hydrogen, that is fixed. And as I said, if it is fixed, mention the name. So we have hydrogen sulfide. Good. Let's look at the last one here. MnO2. That gives what? A variable oxidation number, Mn. So we need to do the calculation. Oxygen here is 2 times 2, and that will give you 4. As I said, please ignore the minus sign when calculating if you want to get it in the fastest way. Just multiply and you are good to go.